unmuted.
Hello everyone, good evening Anant. Hi Vikram. Hi Amit. Amit, you were not there yesterday, if I'm not wrong. Okay. So you can go through yesterday's recording, and if you have any question, you can send that. Yeah, that's fine. You can just send your query through the support team. All right, so guys, I think it's a time to start. And by the way, I have uploaded on my GitHub repository. I have uploaded the GitHub assignment. Those who did not get the assignment, so they can go to my GitHub repository, and here you can see one document, Git and GitHub assignment. So you can see the assignment here and download it. And same for the Docker. So for Docker, I have the assignment in the Docker commands. Docker assignment did not copy it. 1 second. I have copied the Docker assignment. Where did I copy? Give me a second. Let me see Docker. Let me add it quickly. Let me just refresh this page. Yeah, so here you can see Docker assignment. So you can download it, those who did not receive through the support team, and you can, you can go through this assignment. If there is any problem, you can just let me know. Okay, I will update the Docker Swarm assignment as well. So probably within 1 or 2 days. So you just keep watching this. Okay, and also I told you there is a Docker test. If once you complete your Docker, so there is a Docker test I have uploaded on the YouTube, and this is the link for that. Just let me run it. So this is the Docker test. So now I think everything is up to the mark. Those who did not receive the assignment, anything. So, all right. So now today is the day for the Kubernetes. So we will talk about the Kubernetes. All right. So just let me close the unwanted windows. I will keep open this DevOps, my GitHub repository. That I have just pinged Amit. Oh, okay. I pinged to wrong window, to organizer. 1 second. So I have shared the to entire audience now. Okay. So guys, so GitHub is now updated with the Git assignment as well as the Docker assignment. Docker Swarm I will upload within 1 or 2 days. I will send to the support team as well. Okay. Now let us talk about, don't waste the time, much time, and let us talk about what is Kubernetes and why it is required. I will come to that PDF also, but I think first let me start with the notepad. Okay, so what is Kubernetes? Kubernetes. So if I write the spelling Kubernetes, Okay, we call it K8s also. So you might have seen somewhere it is K8s. So K is basically K. This is Kubernetes K, and S is the last character S. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and 8 characters in between. So that's why we call it K8s also. Okay, so you might have seen somewhere, means now once you go through this lecture, you will find somewhere it is written K8s. So K8s means this. K is the starting letter, S is the last letter, and total number of characters inside it is 8. So what is Kubernetes? So Kubernetes is, first of all, it is a portable, extensible, open source platform for managing containers, or I will say managing uh, containerized workloads and services. So far we have we have seen uh, we have seen Docker Swarm yesterday, where we have seen that how that we can manage the containers. So Kubernetes is also a orchestration tool, and this orchestration tool is basically managing the container. It manage the container workload, it manages the container services, and it is available on declarative configuration and automation. And it has a very large, rapidly growing ecosystem. So Kubernetes services, it is highly available, and the services, support, everything is highly available. And this is one of the most demanding technology uh, within the DevOps. So the name of Kubernetes basically originated with the Greek word, which is basically, so this is the Kubernetes is the Greek word, uh, which has the meaning, I think, helmsman or pilot. Okay, so this is the basically a Greek word meaning. So those who are the Greek people, they speak it very uh, properly. This word, we call it Kubernetes. Some people call it Kubernetes. Okay, so it depends, but it's a Greek word. And this is basically, it was the product of Google, and Google has done a extensive testing on it. Okay, so basically Google open sourced this. They open sourced. So before that it was not open source. Kubernetes in 2014. Okay, so the Kubernetes builds upon a decade and a half of experience that Google has with the running production workloads at the scale, and they combine and best breed of ideas practices from the community. So basically this Google is having a very extensive testing on the Kubernetes. So they have almost 10 years or more than 10 years. They basically use this application, and they use this application for production point of view, and it was used for the workload, okay, to scale up the or scale down the workload. It is the, you know because it is tested by Google, so you can trust it, right? You can trust it. It is a very good, and it is proved as well. So in the DevOps world, we use Kubernetes very extensively because our applications are running on containers, and my containers are managed by Kubernetes. So if we talk about something, a traditional, if I talk about a traditional deployment, in the traditional deployment, basically it is very means early, means when there was the physical servers and applications were running, there was no way to define the resource boundaries for the applications in the physical servers. And this is basically uh, when there was the physical servers, there was the issues related to resource allocations. For example, if multiple applications run on a physical server, then there can be instances where one application would take up most of the resources, and with that result, basically what happens, the other applications would underperform, right? So then after traditional approach, we went to the virtualization. In virtualization world, everyone knows that now these days we only use the virtual applications. So virtualization was basically run multiple virtual machine on a single physical server CPU. So virtual machine basically allows you to allows the application to be isolated between virtual machines, and also it provide a level of security as the information of one application that cannot be freely accessed by the another application. So virtual machines is the another deployment type. Okay, and that, or we can say it's a deployment. It's a we can say traditional deployment era, if I say, and this deployment era. Okay. Now after that, after virtualization, what is next? Containerization, right? So containerization, or I'll say container deployment, which is very much similar to your VMs, but they have a very lightweight operating system. Okay, and the images are very less. Containers are basically it is same as virtual machines. It has their own file system, it has on their CPU, memory, process space, and they are basically decoupled from the underlying infrastructure, and they can be portable across the cloud and the operating system distributions. So that was the another deployment era. Now containers are a good way to bundle and run the application. So in production network, we need to manage these containers that runs the application and ensures that there is no downtime. For example, if a container goes down, another container needs to start. Okay, so this is kind of a backup server. So if you give that responsibility to container only, then it will be difficult to manage it. Now that's why Kubernetes or container orchestrations comes into the picture. So Kubernetes basically comes to the rescue. Kubernetes provides you basically a framework to run the distributed system. Okay, so to run the distributed system, so it takes care of the scaling, failover of your application, provide deployment patterns. Okay, so all these things will be taken care by the Kubernetes. So Kubernetes is one of the framework which is basically meant for the Docker or other containers orchestrations. Okay, What are the things which Kubernetes does? So first thing, what is the main feature is the service discovery and load balancing. Why it is going up? Extensible. So service discovery and load balancing. Okay. So what that service discovery and load balancing? So with the help of the Kubernetes, we can expose a container using a DNS name or with some IP address. So if the traffic of the container is high, so Kubernetes can provide the facility to load balance or distribute the traffic. Okay. So this is the feature number one. Feature number one is what? Kubernetes can expose the container using DNS name or IP address. So we will create the IP addresses here. And if there is more load on the containers, then Kubernetes helps us to load the load the balance, basically load balancing it does, and distribute the network traffic so that deployment should be stable. Second is the storage orchestration. So in storage orchestrations, basically what happens, Kubernetes allows you to automatically mount the storage system as of your choice. Okay, such as you can have the local storage, you can have public storage. Public means clouds with storage which is provided by the cloud system like AWS or Google or Azure. Okay, so that is the another feature of the Kubernetes. Next, which one is very useful is automatic rollout and rollback, and we will see all these things practically as well. So automated rollouts and rollbacks. So in automated rollout and rollbacks, basically what we do, we basically define, we describe a desired state of our deployed container. So what is the desired state? So desired state. So this is a very commonly used word, desired state. So desired state is of desired state we talk with respect to container or ports. So here I am talking about container. So desired state of the container. Desired state of container deployment is the right word. Okay. So we basically describe the desired state of our deployed containers using Kubernetes, and it can change the actual state to the desired state in a controlled rate. So what it means, you have said that I need 3 replicas is to run. Okay, so 3 replica to run is your desired state. Okay, actual state is currently 1 replica is running. So now to convert it into 3 replicas, that is to be done by the Kubernetes, and to achieve this desired state, it basically go with a very controlled rate. Okay, so example is something like that. Kubernetes wants to create the new containers for the deployment, remove the existing container. So these are the some examples of the automatic rollout and rollback. So if say an example, some image is running and you want to upgrade that image, or you want to degrade that image, then that is also, if you roll back to the previous version. So these all the things are done in a very controlled manner. Okay. Another feature which is related to Kubernetes. So guys, just we will discuss some theory, then I will jump to the practical also. So I just want to make a base of this, what is Kubernetes and why we are using. And next is the self-healing. So basically Kubernetes restarts the container which get failed, or it replaces the containers, it kills the containers that don't respond on the user defined health check. Okay, so this is basically, this concept is called self-healing. Next is the secret management, secret and configuration management. Okay, secret and configuration management, basically what Kubernetes allow you to do. It allows you to store and manage the sensitive data such as your password, authorization tokens, SSH keys. So you can deploy these updates into your secret database, which is basically uh, a part of the master node or manager of the Kubernetes. Okay, so basically we can keep our secret information or confidential information into a database, and that database is basically maintained by the Kubernetes. Okay. Now, what is uh, not Kubernetes? What is not? So these are the things which is provided by Kubernetes. So what Kubernetes is not. Okay. So Kubernetes is not a traditional. Okay, it's not traditional. So Kubernetes basically operate on container level. So Kubernetes maintain the thing on container level, then hardware level. Okay, and what else? So we have Kubernetes is uh, basically we write some code which is to manage. So it basically does not deploy the code. So yes, that is the next one. It does not deploy the source code and not to build the application. So Kubernetes is not used for deploying the code or the application like your CI/CD pipeline. So this is not a job of Kubernetes. Okay, Kubernetes comes after the container get created. So these things are basically handled by on the container level, but Kubernetes comes after container. So if you have some application level services, so it will not support it, does not support application level services. Okay, such as your message queue or some data processing framework like your Spark, MySQL database. So Kubernetes is not like that. Okay, Kubernetes is not for logging. Kubernetes, or I will say it is does not dictate logging, okay, and monitoring or alerting solution. Okay, so it is not for this purpose. And so these are the some of the features which I just wanted to explain before starting the Kubernetes. So on top of all these features is Kubernetes is not only managing the it is not only managing the containers. It basically eliminates the need of the orchestration wherever it is required. Okay, so Kubernetes is basically a set of independent composable processes which is continuously running. So Kubernetes is helping to keep it running all the time, all the containers. Anyone has any question, any doubt from this? I think it's not a right time to take the questions. Let me just first go through some more part of this, then we will discuss about the. So let me open the where is this is Kubernetes. Okay, so where is that? Okay, 1 second. Let me just. Okay, so let us talk about the what is Kubernetes. So now you might have some ideas. Okay, Kubernetes is a container management technology developed by the Google Lab, and now it is basically hosted by the Cloud Native Computing Foundation. So basically, so now it is Kubernetes is managed by or developed by CNCF. Is also called K8s open source for the automating deployment, scaling the containerization. It supports the range of container tools, including Docker. Kubernetes v.10 was first, so this was the first version, and Kubernetes is one of the most visited GitHub repository. Okay, features we have already discussed. So if you get the chance, you can go through all these features. Now let us talk about this architecture. Okay, so whenever we are talking about Kubernetes, so before coming to this, I have one more. Okay, so few more things I just want to say. What is Kubernetes? It is container orchestration engine, manage containerized application at large scale. It is cluster management, it is scheduling, it is service discovery monitoring, it is secret management, and much more. And Google basically now it is Google has done a extensive testing on it. And if you see Google if you see a little bit history on that, more than a decade Google work on it, runs billions of containers every week. Gmail, YouTube, search, all are running on containers. Borg proprietary container manager of the Google. So this was the earlier stage when Kubernetes was used in the Google. Container orchestrations engine on the Google Cloud. Okay, so this is the container orchestration engine for the Google Cloud. Who is using Kubernetes? These all are big companies, they are using Kubernetes. Let me first talk about this way, how to what is the master and what are the worker node components. Then I will jump to that PDF. So basically what happens in Kubernetes, we have one master node, one or more master node, and we have worker nodes. Okay, so this is master node, this is worker node. So in this case, I'm showing only one master node, one worker node, but not three worker nodes, 1, 2, and 3. And these worker nodes, this box which you can see inside it, that is basically called the container. And the circle, it is called pod. So what is pod? We will discuss. So pod is basically the atomic unit of this Kubernetes. So what is the meaning of atomic unit? So like in virtualization, VM is the atomic unit. In Docker, container is the atomic unit. So same way, in the Kubernetes, pod is the atomic unit. So everything when we talk about the Kubernetes, we will not talk about container, we will talk about the pod. And that pod can have one or more container inside it. Okay, so if you see, these all are the pods which is in the circle, and in these boxes which is showing here, these are the containers inside that pod. So contain logically created containers, I will just club it into one pod. Most of the time we use one container in a pod. So that is basically pod. And here this is the master server, and master server when so Kubernetes basically runs on the master slave architecture. So in master slave architecture, basically what happens, there is a master and there is one or more worker nodes, and they make a cluster. And what is the purpose of these worker nodes? They are basically connected to each other, master with some token key, so that they can communicate to each other. So master is going to issue the command and worker node is going to execute the command. So say an example, master node is saying, okay, create a pod network. So master is saying create a pod network, and it is getting created on the worker node. Master is saying run a service, and that service is going to run on the worker node. You can make something like your master node also as a worker node, but that's not a real-time scenario. We segregate master node and the worker nodes. So worker nodes responsibility is only to execute the commands which is given by or issued by the master node. So it means in the Kubernetes, at least there are two components. One component is master and other component is worker nodes, and they join together and make a cluster. And the atomic unit of Kubernetes is pod. Pod is basically have one or more than one container. If it has one container, we call it single container pod. If it has more than one container, we call it multi-container pod. Okay. Now, after that, so this diagram I think is clear to everyone, where master is issuing the command and this slave or slave is not a right word, so we will call the worker nodes, is basically executing the commands. It is consisted of at least one master node. It can have up to 5,000 worker nodes. Pod is consisted of one or more containers. So what is pod? Pod is containing one or more containers. containers is where actual application is running and inside the container. So your application is running in the container and container is inside the pod. So these are the things. Now let us talk about Kubernetes master. So this master, so here the master architecture and the worker node architecture is different. So there are different components related to that. Okay. So let us first talk about the master component. In master, we have the API server. So what is API server first of all? Those who are programmer, they means those who from the programming background, they know what is API servers. So in general, what I will say, API server is a server which takes the API request and execute API objects, execute with the API objects. What are the API objects? So in master component, if we take ports, if we take services, replication, controller, etc., all these are the API object, application programming interface object. And the API server, so API server does a REST operation. So REST operation is, I'm not going in much detail of what is API server. This is a very vast topic, but it is not, we don't need to go so deeply into this topic. You just consider that there are some objects which is to be executed with the API server, and to execute this to execute these commands or to execute these operations of this API object, we need API server. Okay, so API server services REST operations and provides the front end to cluster shared state through which all the components interacts. So if you see this diagram, so this is the kubectl and UI. So kubectl and UI is basically the commands which we are going. So say an example, you want to see how many ports are running. Okay, so this command is issued by the CLI or kubectl, and this is an API command because I want to see the ports. So ports is an API object, and that command will go to the API server, and then API server will decide what to do. Means whether I need to which API object operation to execute it. Okay, so this is the API server. Second is the scheduler. So what is the scheduler? Scheduler is basically, it watches the newly created ports that have no node assigned. So now the ports are basic unit of this. So this port is get created. Now scheduler is watching whether this particular port has any worker node assignment or not. If it is not assigned to any worker node, then scheduler discover in the worker nodes which worker node is suitable for that port, and it will basically run that port onto that on that particular worker node. So that is the purpose of the scheduler. So API you understood, scheduler basically everything will be initiated by API server only. Okay. Now next is the control manager. So as you can see, see that control manager who is managing everything, right? That is a control manager. So similar kind of work. It is basically infinite loop, you can say. It is an infinite control loop, and it is basically checking the health. It is checking everything is running fine. So this is basically the work of the control manager. So the Kubernetes controller manager is a daemon. So daemon is basically background long running process that embeds the core control loops shipped with the Kubernetes. Okay, so it is a control loop which is basically get installed when you deploy your Kubernetes. In the applications of robotics and automation, A control loop is basically non-terminating loop that regulates the state of the system. In Kubernetes, controller is a control loop that watches the shared state of the cluster through the API server and make the changes attempting to move the current state towards the desired state. Examples of controller that ships with the Kubernetes today is the replication controller, endpoint controller, namespace controller, service account controller. So these all are the controllers. So we have some components in the Kubernetes like replication controller. So replication controller is basically it's a controller which continuously checking whether the desired state of my pod is running or not. So desired state is 3, say an example 3 ports to run. So it is keep checking whether ports are running or not. Okay. So this is the example of this. Now next is the etcd. So etcd is basically a secret management. So it is just like a database which stores your secret information or confidential information like your password, your authentication. So these are the components of the master. Now let me take the question. If someone has any question related to what is Kubernetes and what is master component. Okay, good. I think I explained perfectly. Okay, someone is asking question. Okay, what is the minimum objective of the Kubernetes? Is there any alternative to? Alternate is Docker Swarm, and but it comes with the what is the main objective? Okay, so the main objective is right Vibhakar. So Vibhakar main objective is the orchestration, means maintain the containers. Okay, and alternate is Docker Swarm is one of the competitor. Okay, control manager is basically infinite loop, Rijwan. Basically, it keep monitors. So, say an example, there is a replication controller. It keep watching the state of the pod, and if it finds that, say an example, there is a pod should run with the three replicas. So, replica control manager is basically or controller. It is watching that. It is watching that particular desired state is achieved or not. If it is not achieved, or say an example, one port is down, so two replicas are running. So it is the responsibility of the replica control manager, replication control manager, to maintain the desired state. Is it necessary to use K8s? Yes, yes, I think he's asking. Puneet, yes, that is required, right? Because this is the one of the hot topic and lot of questions has been asked through in the interviews, and it is a part of the DevOps. Is this the Google product? It was the Google product. Now it is contributed to CNCF. Does that mean they are using Docker in Google? Yes, so yes, so internally Docker or some container. I'm not 100% sure. Google is all the applications are running on Docker, but they are using containers. When already we have the Docker container. See, Puneet, this is the Docker container. Now we need to manage the containers, multiple containers. Please explain the point storage orchestrations and automatic rollout. Okay, so storage orchestrations means basically when we talk about the storage orchestrations, so Kubernetes basically allows you to automatically mount the storage system of your choice. Means so you want the local storage, you want the public cloud storage. So that is the storage orchestrations. Rolling update means automatically it will without shutting down your application, it can roll out or put the rolling update to your application. Is it clear to you, Ashik? They are using other than Docker. Could be, actually. I'm not sure that Google is using all the Docker or something their own, because Docker has their just yeah, that's what I'm saying. So I'm not sure. I'm saying that these are running on the containers. It is not necessarily on Docker. K8s will run on the no. So Kubernetes, yes. So there are two components, Venkat. One component is master and other component is worker node. So there are different components. So Kubernetes worker node component, we need to run it on the Docker server. What is the difference between Docker Swarm and K8? So I will come to that, Anand. So that we will see, Bhaginath, that on which port it is running. That difference we'll see. No. Docker Swarm is not a worker node. Docker Swarm is another orchestration tool. Okay, Docker Swarm is another orchestration tool, and Kubernetes is another orchestration tool. Okay, so I think I have answered all the questions. Now let me go to the worker node component. So when we are talking about the worker node components, they are basically two components. One is kubelet and another is kubeproxy. So all the request comes to from the master node and it will go to the worker node. So kubelet is basically a, you can say, local worker node health check system. And what it does, it basically check the health of the ports inside the worker nodes. So what it does, it takes a set of port specification that are provided through the various mechanism. Primarily it is through the API server, and ensure that the container describes in those port specification are running and healthy. So kubelet does not manage containers which are not created by the Kubernetes. So kubelet is basically is the one which checks that this port specification is available on the network or not network, on the worker node. Okay, and these, from where it get the port specification? Through API server. So API server is running a command that I need to run a port, and that port is multi-container or single container, and there is some other specification. This is the image of the container. So everything on the worker node side is handled by the kubelet. Now kubeproxy. So kubeproxy is basically it also runs on each worker node, and what it defines. So say an example, this container has some some website is running, or there is a this is a web server, and now if you want to expose this web server outside the world, then you use the kubeproxy. So kubeproxy is basically can do the TCP, UDP, and STP stream forwarding, or on the round robin basis, right? So these are the two components of the worker node. Can master component run on the different servers, and they have to be installed on one server? Yes, master is a separate server in real time, and we will create a separate server, Vikram. Alternate to Docker. Yeah, there are other containers is available, right? So, but mostly it is, what are ports? Is it container? So ports is basically having the container inside it. Okay. So what is port? Port is basically a, this is the atomic unit, means it's a basic unit of it is the basic unit of the Kubernetes, and these ports are having the container inside it. So okay, so can two master servers running on the same time manage the worker nodes? See, Rajwan, actually mostly in the real-time scenarios, you can have multiple servers, but we run only one server, which with the hi-fi configuration, and because most of the executions are happened on the worker node. Okay, so you can have multiple master nodes as well. Okay, kubelet is not managing the containers which are not created by creator, but we are creating the containers using the Docker. So yeah, so there will be a specification. So say an example, you are running one container, you have created your own container, but this is not inside the pod. When it will be inside the pod? When there is a when it comes through the API server, or if it is created by the Kubernetes. If it is not created by the Kubernetes, it's not basically maintained by the kubelet. So kubelet is only looking for the pod network. Worker node can run standalone containers along with the kubelet worker node. Worker node can run standalone containers along with kubelet managed containers. Actually, kubelet is the part of the worker node. It's a component of the worker node, Vikram. Okay, so someone was asking is there any other containers are available? There are some containers are available. One is LXC, OpenVZ, Mesos, okay, Core OS. Okay, so I think there is one more, which is I believe. So mostly, actually, these are the some other containers. I think someone was asking. That. Worker node can run standalone. This I have answered. Okay. Okay, so I just lost that question who was asking this, but this is the basically I think I answer all the questions. Right. can a container Docker will have pod and known pods? Can a Docker will have pod? Actually, Docker containers, basically when we are talking about containers, so containers are inside the pod, right? So that is the basically what I'm trying to say. So if you see this diagram, so this is the pod, and within pod we have the containers inside it. So you need to install some application, right? So that application is nothing but the Kubernetes application, and we need to install the master component, and we need to install the Kubernetes worker node component. Okay, so now let me proceed further. Why it is not showing? This is page 1, this is okay. Now you can see this is the complete architecture of the Kubernetes, and here you can see these are the master. So we need to install master separately, and we need to install worker node separately. So there will be a different components related to that, and these are the components which I have already explained. Okay, so this is the basic architecture of that. Let me go through one more slide, and then we will see the. So this is Kubernetes pod. What is pod? Pod is basically the basic unit or atomic unit of scheduling. Like in virtualization, we have VM atomic unit. Docker, we have container. So same way in the Kubernetes, we have the pod. So a Kubernetes pod is a group of containers that are deployed together on the host. Okay, if you frequently deploy the single containers, you can generally replace the word pod with the container and accurately understand the concept, right? So if you think only one container, then you can say it is the pod. Means if this pod is having only one container, so you can say container or pod, you can say, but in actually it is within a pod. In Kubernetes architecture, within a pod we have the container inside it. Okay, so you can see now what is the pod deployment. So when we are talking about pod deployment, that I will come later. Let me just see what is in our other slides. Okay, so we have done this features. Okay, so this one I have explained now. What is master and what is worker node. So on master node, you can see that we have etc etcd. We basically call not etcd, etcd, API server, scheduler, controller, manager, and on machine. Actually, we need the Docker also. So Docker on the worker node, kubelet, and Kubernetes proxies. etcd is basically which have the secret management data. It's a secret management database where you are storing your confidential information. Okay, this is again, you can go through this. Okay, I have explained all these components. Okay, so we are done with our theory. So now it's the time to do the practical. Okay, so Kubernetes, okay, someone was asking a question, what is the difference between Docker Swarm and, I'm not sure whether it is here or not. Let me see if I have the difference. Okay, it is not here, but I have on my GitHub notes. So and you can find all these the LMS portal. You can find these slides which I was sharing, and the slides which is not there on the LMS. You can go to my GitHub repository, and here you can find these two slides which I was sharing. And I have Kubernetes some separate kind of a notes. And here this is basically a cheat sheet, you can say. Here I have Docker Swarm and Kubernetes difference. So what is the difference? Docker Swarm, when you install it, so in yesterday lecture I explained you why Docker Swarm need was there, because people were started using Docker, and Docker was the container tool. So now when these containers are used in production, so everyone wants that it is to be managed. So Docker itself has created Docker Swarm. So you need not to install anything extra to install the Docker. So Docker Swarm get installed when you install Docker. Okay. So it is very easy to install because you just need to write a simple command and apt install docker.io. Docker Swarm will get installed. But Kubernetes is not like that. So we will see today that installation, how to do the installation, and that is basically a very complex way to install the Kubernetes. Okay, so first difference is that Docker Swarm is easy to install and Kubernetes is installation is complex. The second difference is Docker Swarm comes with a very limited features. Okay, Docker Swarm comes with very limited features, whereas Kubernetes is full of features only. So that is why its installation is complex. So in the Kubernetes, when it comes with a lot of features and it all the task which I have just explained, the master and the slave or the worker node. So whenever there is a process happens, there is a control loop, there is a control manager, there is a secret management, lot of features are there. So if we run orchestration on Docker Swarm, it is fast because it has not to do lot of processing. Lot of processing is to be done by the Kubernetes. So as compared to Docker Swarm, Kubernetes is slow. Kubernetes comes with lot of features, that these features which I already explained you, but Docker Swarm comes with the very limited features. Okay, so this is the difference. Someone was asking what is the difference between these two, and this is basically not the final notes, but it is just a cheat sheet. Okay, now when you do the installation, if you want to, now it's the time to install the Kubernetes. But when you install the Kubernetes, there are a lot of ways. One way is the kubeadm, which we are going to use. Okay, but this is not the only way, but this is the very commonly used or the generic way to install the Kubernetes. Generic way means it is basically it is applicable to all type of the systems. So when you have the bare metal means you have a virtual machine or like your Linux virtual machine. We have the EC2 machines. So then we use the we prefer to use the kubeadm. If you want to create a virtualization, means if you want to use on the virtual box uh, or any virtualization environment, then you can use the Minikube. So this is the another installation, means any one of these we can use. It depends on which environment you are using. If you are using the AWS, if you want to use the AWS environment, not EC2 instances, but AWS environment if you want to use, then you can use KOPS, KOPS. And if you want to use on the Google platform, then you can use the GCP Kubernetes installation. So what I'm going to do, I'm going to show you these two, Minikube and the Cube ADM. So let us first start with the Minikube. So Minikube is basically a virtualization environment. So for that, I need to have installed the Oracle VirtualBox, and your virtualization should be enabled. So these are the conditions when you want that virtualization is to be enabled, when you want the Kubernetes is to be installed using Minikube. So my virtualization is there. Actually, I was running it for the another batch. So, but if you double click on it, so you can see my Minikube is running over here. So basically what you need to do, you need to go to one website, and this website I can give you on the chat window. Okay, so someone is asking, Ashish, does this not mean that a good feature improvement of Swarm by Docker include all features shut down the Kubernetes? Actually, see, Docker main purpose is for the containerization. So they just added the Docker Swarm for some. Uh, they added this to maintain the Kubernetes, to maintain the containers. But Kubernetes is not only maintaining the Docker; it can maintain the other containers as well. So that is also one of the difference. So if you are running with that, it is basically means Docker is the uh, one of the favorite container. But as I told you that Apache Mesos, LXC, OpenVZ, right? So if you want to use these containers, Docker Swarm is only for Docker, right? Minikube is more like a test environment. That's right. Minikube is basically on one server you are running everything. So we are not going to use the Minikube. We are just going to I will show you how to do that. So this is the URL. You can go to this URL, and here you can see, because I'm running with the Windows. If you are running with Mac operating system, Linux operating system, but you need the uh, virtualization enabled. Okay, so now I am using Windows. So what is the minimum requirement for the Minikube? One is that Windows 8 or above, hypervisor, virtualization, which is basically used for that. It is to be available, and hardware virtualization support must be enabled in the BIOS. That settings you need to change, and minimum 4 GB RAM. So what you need to do first you need to check the system information. So what is the system information? So what I will do, I will open my PowerShell. Let me increase the font. Oh, this is cursor, sorry. This is fine. Where is my font? Font is here. Okay, so what you need to do first, you want to see the system information. So to see the system information, you need to write this command, system info. Okay, so it will basically gives you your system information, and here you need to see Hyper-V requirement. It is enabled, yes. So all these things should be yes. Okay, so this is the one thing which you need to check. Okay, and this is the first requirement. And second, what you need to do, so these all are yes. Now if you need to enable it, you need to run this command. In our case, it is already enabled. And you need to download Minikube installer. So you need to click on this. Okay, and after installation, you will get one exe file. Okay, I'm talking about Windows only, and your virtual box should be up and running. Right, so now you need to install, and it is a very simple installation. And once it is downloaded successfully, then you need to install it, and after that you need to just run. You can run with the minikube start command. So you need to go to your command prompt and execute this command. So okay, so I'm here. I'm just writing the command minikube start. So it basically start up my minikube. So it is preparing Kubernetes. Okay, and on my virtual box. So it is running basically in my case, because for the previous batch it was on. If I say power off, and let me do it again. Okay, now it is running. So if it is first time it is getting downloaded, so your virtual image will get downloaded and then it will start it. But in my case, it is already downloaded and now I am running it. So let me see, it is running. Yes, now it is running. So let's wait. So it takes some time to start it. So if you remember that it was in the power off state. Now it is started with the help of the minikube start. Okay, so it is still booting. It is taking time. So this is basically one platform which you can use for the testing purpose, because on one node you are having worker node and the master component installed. So this is basically for testing purpose if you don't have any hi-fi environment. And let me see if someone is asking a question. Even for the CubeADM bare metal v Oracle, yes, you can use, yes, that is a separate, right? So you need to install Linux box. I will deploy on a, so I will show you on EC2 machine, I will show it to you, Venkat. We need to install Minikube inside Oracle VirtualBox base system. Yes, it will automatically get installed when you write the Minikube. You need not to uh, download and attach with it. Once you write Minikube start command, automatically it will detect the image and it will attach to the VirtualBox. So VirtualBox should be there. In your case, Minikube is configured with virtual. So it is not configured, actually it was not there. So you can, once you try it, you can see that Minikube, okay, or let me do one thing. So now it is launching. So if there is no image available here, okay, so what you can do, once you write Minikube, it automatically download the image and it will automatically attach it. You need not to do any kind of operation to add it. Only you need to run the Minikube start command. Okay, so it is relaunching the Kubernetes using, so it is doing some activity. So let it complete. Okay, so now my so you can see kubectl is now configured to use Minikube for best result. You can use kubectl this. Okay, so we are not going to work on Minikube. I just want to show you that how to install the Minikube and how can we make virtualization enabled in the firmware as a, so that is in the BIOS setting. You need to change Vibhakar. In the BIOS setting you need to change it. I remember it fails for me with the below error. Do you have Docker on the Windows? No, nothing. I have not installed anything. Minikube is not recognized. So you have not installed Minikube software. First you need to install Minikube software, Deepak. I have installed it. Oh. After installation, what is the error? Object not found. So there is something wrong happen into your installation. In that case, you need to reinstall it and check it, because it's a very simple installation. There is no complication in this. Okay, now you can see Minikube IP. Okay, so it will give you the IP address of your Minikube virtual machine. If you want to go inside the Minikube virtual machine, you say Minikube SSH. Okay, now I am inside the Minikube. Okay, fine. So now I am inside the Minikube. So here I can run my commands. Say an example, if I say kubectl, so now I am inside the virtual machine. And if I say get port network, not this command. If I come out of this and if I say cube, I don't know whether kubectl will get installed, because we very rarely use it. I never use it. Get, I think my command should start with the minikube. And if I say get port, yeah. So now it is downloading kubectl dot. Okay. So this is one of the command I'm trying to run it. Okay. So to see my ports, whether it is running or not. Okay, so it is saying no resource found because I have not created any port there. Okay, so now you can see my minikube is installed successfully. Can you please ping what all the software are required for the Kubernetes? That we will discuss, Vibhakar. I will show you the demo. Okay. In this situation, Windows machine is the master node. No. So everything is in the minikube, Rajwan. Means master, slave, master or worker node. Everything is minikube. Everything is under one machine. Okay, so this is the installation of the minikube. Now we need to go through kubeadm. Could you please explain it in the Linux OS? So we will now do it. So in the Linux box, Bhaginath, you need to enable the virtualization, and you need to. So these are the requirements. So what you can do, you can go through this. You can go through this URL. This is for Windows. I have shown because most of us we are using the Windows. Same thing you can do with the. You can go to Linux. So if you go to the Linux, so these are the instructions. You need to follow that. Okay, or these are the requirements. So you need to install all this, and then if you write minikube, so you need to enable the virtualization as well. Okay, so same link you need to use for the Linux. So I would suggest don't waste much time on minikube. Better to do with the kubeadm installation, because this is one way basically, and which is in the production we don't use minikube. We use the kubeadm or other AWS or Google. Those who are working on the AWS or Google world, they work with the COPS and GCP respectively. Can you demo minikube? What is that? Can you demo minikube being used to manage the container? So that's what I'm saying, Ola. We don't waste much time on this. Better to spend our time on the real-time scenarios. So once you complete that, after that commands are same. Commands are same. You just need to write minikube and your Kubernetes command. So I will explain all the commands on that. Okay, so in minikube basically we are okay. So guys, please don't get confused. So minikube is one environment is given to me. Now if you see, I have run this command minikube kubectl get ports. So it is saying no resources is found because I have not created any port. So these kind of things we will discuss in the kubeadm. We will create one complete environment where there will be a master node, and I will create one worker node, but you can create multiple worker node with your choice. And we will create that environment, and There we are going to create our ports, services, replication controller. Once you get comfortable with that, then you can come back to your minikube and run those commands. Okay. So I had given you one example, that minikube kubectl. So kubectl is basically the like in Docker you are writing Docker and then commands. Here in Kubernetes we write the kubectl and then the command. Okay. So we will see that. Okay. So before starting this, so what we can do now next, we will take a break, I believe. So before taking a break, let me just show you one website. So we will go to Google and say Cube ADM installation. Okay, Cube ADM installation. So you will find the first link which is saying installing Cube ADM Kubernetes. Just click on this. Okay, and here are some steps given depending upon which operating system you are using. So we will use these steps to install. So if you see down here, so we are basically going to use these three components. One is the kubeadm, the command to bootstrap the cluster. Okay, so we need to install these three services we are going to install. One is the kubeadm, which is the command to bootstrap the cluster, and next is the kubelet, the component that runs on all the machines in your cluster and does the thing like starting the ports and container. So kubelet I have already explained you. kubectl is basically the command line utility to talk to the cluster. kubeadm will not install and manage kubelet and kubectl for you. So you will need to ensure that match the version and Kubernetes control plane you want the kubeadm to install for you. So it's not a dependency. Basically kubeadm is if it is not now these days it install, there is no problem. But if it does not install, so it does not install or manage kubectl. So before running your code, you need to check it out that my kubelet and kubectl is installed properly or not. And down here you can see there are some steps which are given here, and these steps are basically how to install the Kubernetes. So we will do that. So I think it's a better way that we can take a break, and after the break we will start the installation. So we'll take the 15 minutes break. We'll take a 15 minutes break here. Makes nice and easy for the okay, Ashish, can we do the on Ubuntu? Yeah, we will do on Ubuntu only. Yeah. Alright guys, so we'll meet after 15 minutes. So let me just start the timer. Okay, everyone, I'm back. So what we are going to do here, we will install the KubeADM. Okay, so first let me start my AWS machine. One second, I'm logging. So I'm logging in to my machine. So I will go to the EC2 instances. Okay, so far there is no instances are running. I'm in the Virginia region, right? So I'm going to create Ubuntu instances. So here I'm going to use Ubuntu 18.04 and prettier. So I'm going to take two instances here, one for the master node, one for the worker node. And next, add storage. I will take the default settings. Tags I am not adding. And then I'm going to use the security group. So I'm opening the firewall for each. So I already have one group, all traffic. So I'm selecting this, review and launch. So I'm using this key, view instances. So I will make one as a master. I call it kmaster, and other I will call it kslave, k worker node, not. Okay, so k worker node. Okay, you can give any name, whatever you want. Alright, so one is running, one is in the pending state. So let the other two start. Okay, now both are running. So what I will do, I will first connect to the master. I will take this connection string and I have installed git bash. So let me close this. I don't need this. Let me close this as well. Let me close this. I'm just closing all unwanted windows, sorry. So here what I'm going to do, I'm going to click on git bash. My key is available here. So I'm going to paste that. And this is my master. I'm going to connect. And I will say yes. And that green color is master, or what we can do, we can create the we'll change the name. So we'll say host name master. Okay, sudo su. Let me log in with the root user, and now I'm saying host name master. Okay, now I need to change my host name file as well. So vi/etc/host name. Okay, and here I will name it master. This is not a mandatory step, but it is better. So I'm writing bash. So now this is my master machine. Now, first thing what I will do, I will update the repository, git update. Okay, now next what I will do, I will install Docker. So apt install docker.io-y. So I'm installing Docker on this machine. Okay, so meanwhile it is getting installed, let me connect to my other machine, which is my worker node. So I will select this, copy, and I will go to my downloads, and I will change the color for this. So I will say foreground color, let me make white. Okay, and this is my worker node. We want to save yes, and sudo su, and what I'm going to do, this is my worker node. So apt update first. Okay, this is done. I will change the host name. I will say worker node, and I will change into the etc host name file, and I'm just giving a name worker node. I will save it, and I'll say bash. Okay, this is worker node, and now I'm installing Docker. So for worker node, Docker is must. So I'm going to install apt install docker.io-y. Okay, so this is the step 1 which we have done. Now let me go back to my kubeadm. So first thing that you need to install apt curl command https. Okay, so I'm just taking this and I'm going to install this. So this is on both the nodes. So some installation is common to both, means for your master as well as on worker node. So I'm installing this. Okay, now let us see next command. You need to use a GPG key. So GPG key is basically for signing in purpose. So I'm using GPG key and it should return OK. Okay, so this is done. This is also done. Okay, next I need to update the Kubernetes list into my repository. So I will copy this This is done, and same thing is here, done. Now next is I just need to update the repository now. And same thing is here. Now I need to install all these three because we need to install individually, as it is told that KubeADM is not responsible to install all these services or component. So we need to install all this. Now this kubectl or kubelet, kubeadm, I need to prevent for the upgradation. Okay, so for that I will mark it as a hold. So this is the command which I need to execute it. Okay, same thing is here. So now the common installation is over. So both the networks, whatever the minimal requirement is required as a worker node or a as a master node, so that is done. But now we need to segregate. We need to say that this is master node and this is slave or worker node. So for that, basically what we are going to do, we need to make this node as a master node. So you can go through this documentation. I'm directly jumping to the next step, using KubeADM to create a cluster. So we need to initialize our master node, and to initialize the master node you need to write this command, kube init. KubeADM init command. Okay, so I'm going to create the KubeADM init command. Next, this is the API server. So API server will be my master, right, where the API server is going to install. So API server, advertise address. If you remember, in the Docker Swarm also we have run similar kind of command, so where we have mentioned the advertise address. So here I'm saying advertise address and go to, give a space and paste. Okay, so this is the advertise address equals to my master machine IP address. So my master machine IP address is this is my master machine IP address. I will take the private IP. Okay, this is my master machine IP address. Now next is, actually we need to create a pod network. Okay, we need to create a pod network, and to create a pod network, what we do, we use some plugin, and that plugin is, you can find it somewhere down here. You can install only one pod network per cluster. Okay, so what we need to do, you can use whichever is suitable, but mostly means any one of you can use it, but I'm very comfortable with Calico, so I'm selecting this Calico and this pod network. So what I'm saying, I'm going to create a pod network which is of this range. So the pods which get created, it will be basically communicating on the pod network. So what is that pod network? So let me just show you here. Here. So in the port networking, basically what happens, you have port 1 and port 2. Okay, and port 1 is having 2 containers, port 2 is having 1 container. So they are basically, each port is having one IP address. And if there are multiple ports are running on that, multiple containers are running on that port network, then these are separated with the port number. So say an example, this is the main container and second is the supporting container. So main container is running with the 8080 port and supporting container is running with the 3000 port. So I am saying this container, which is my this container. Okay, this is accessible with port network IP address. So these IP address basically I need to define. So I will explain this one more time, but I need to create a port network where these IPs can be assigned. So for that, I'm using Calico. That's what my purpose is here. So I'm using a Calico which has a CIDR range. CIDR range is basically your better to use Anand the private IP address. Okay, and I'm using this port network for the Calico. So I will go back to my master machine and I will give one space and paste it here. And we need to be very careful to run these commands because if something get messed up, it is very difficult to resolve. You need to if half of the Kubernetes is installed and half is not installed, you need to do a lot of work. You need to release the ports and means whatever the issues come. So be careful when you are installing it. Now, when you run this command, okay, there will be one error. The error will be basically, so the port network, basically when you are running the ports, right? So this is port 1 and port 2. Both are running on some port network and that port network has a CIDR range. So CIDR range is nothing but how many computers you can host on that particular network. So for that, I am using the Calico. Okay. So when I run this command, so let me run this. PDF I already shared on my GitHub, Venkat. So it is already there. Okay. Now it is giving some warning that it is saying Docker service is not enabled. Okay. So we need to run this command. That is fine. Warning you can ignore. But there is one error. When you run a Kubernetes, it needs, because Kubernetes is little bit coming with the hi-fi features. So it is saying the number of available CPU is 1, which is less than the required, which is 2. So if you want to run the CPU, you need 2 CPU. Okay, but I'm fine with 1. So if you want to ignore this error, and this error will not impact anything. So what you can do, you can say space, and here you can find ignore. Without quote you need to take ignore errors equal to. Okay, I will copy this. I will paste it here. Equals to, and I'm saying number of CPU. You just ignore this error. If there is an error related to this, just ignore it. Number of CPU, enter. Now my installation is started on the master. So it will take little bit time. Okay, so now it is giving me one string. which is saying that use kube ADM to, now this basically I will give it to my worker node to join it. So I will just right click on this and say copy. Okay, and I will go back to my worker node. Okay, let me clear the screen and I will paste it here and press enter. Okay, so this is not documented. So actually documentation for this will not work because you need to go to the multiple pages. So better whenever you want to do the installation, you watch this video. If you do it 1 or 2 times, this will be clear to you. Okay, so now it is saying it is joined. This node get joined. Okay, so you can see with the help of the kubectl get nodes command. But before going, so this installation is little bit complex. I understand. So to start using your cluster, you need to run the following command as a regular user. So these are some variables you need to set it up. Configuration settings. So you need to run this command which is before your join command. Just copy this and run it here. Okay. Now, when you are creating a pod network, there is one more thing you need to do. You need to run, last step is to connect, yes. So this is the last step, and last step is to connect with the master and with the slave, yes. So it is just, now what you need to do, you need to run this. So there is a YAML file for the Calico, which basically performs the last step to apply the networking or to create the pod network. So I will copy this. I will go back to my master node and I will run this. This will run on the master node. Okay, so it will just create some pod network for me. That's it. Now if you say kubectl, so kubectl is basically the command to start something. So kubectl get nodes. So it will tell what are the nodes which is in your cluster. So you can see there are 2 nodes. One is master node and another is the worker node, but both are in the not ready state. So it will take some time to start up. So now you can see both are in the ready state. Okay, so now we are done with our installation. So I know it is little bit complex, but believe me, if you do it 1 or 2 times, if you follow how I went to this website and how I follow the steps, same way you just do it 1 or 2 times, it will be very easy. Or you just make your notes for this. So this is the cube. We are installing Kubernetes by using kubeadm, and I installed it on a bare metal. Okay, so now I am ready to run my commands. So I think anyone has any question? Okay, I don't see any question. Okay. Now let us talk about pod. Okay, so I am interested here to talk about the pod and pod networking. So pod I have already explained you. Whenever you want to create a pod, there is a way. The way is that you need to create a manifest file. So what is manifest file? Manifest file is a YAML file. Okay, manifest file is a YAML file. YAML file means where you are writing some. Remember yesterday we have created one YAML file for the Docker Compose. Same language we are going to use here, which is the key value pair, and I will explain you all this thing. So first I want to create the atomic unit of my Kubernetes, which is pod, and inside the pod I want to create a container. Okay, so whenever you want to create a pod, you need to submit a request to the API server by using manifest file, and that manifest file has the complete pod specification, means which version, what is the image, what is the what is the image and what is the version of the image, is there any replica set, everything is explained within the manifest file. And on the basis of these specification, master node issue that command to the worker node, and on worker node we are basically running those pods. So your pod can be a single means it can be a replica, or it can be a single pod which is running on the pod network, but it can be a single node, means it can have only one container inside it, or it can have multiple container inside it, so that depends, right? But if there are multiple container, so say an example, there are, one second, so for example there are two containers are running in a pod, which is the main container and the supporting container, and these two containers can run on one IP address. Okay, so in the every pod has one IP address, and that IP address is provided by the pod network, and this pod network we have installed by using the Calico. So now one pod has one network, but it has two containers or two or multiple containers. So if you want to use these containers with the port IP address, then you need to use the port number, port number. So here 8080 is the port, here 3000 is the port for the supporting container. So if you want to access it, you can access with the port number. If there is only one container, right, so it will have only one port number. By that port number you can expose it. Now there is a possibility that these two containers wants to communicate to each other. That is also possible. If two containers within a pod they want to communicate each other, they can communicate with the help of the local host. Okay, so before that, these are pod 1 and pod 2. These two ports get created, but there is only one pod network. And if container 1 wants to communicate with the container 2, then they are basically communicating through the local host. Okay, so now let us talk about a pod life cycle, and I'm talking more on the pod because this is, if you understand the pod, then basics will be clear for you. So here, pod life cycle. So what is pod life cycle? Once you start the pod, once the manifest issue the command to API server, and API server is going to create the pod network, ports in the pod network, then in the beginning it is in the pending state. If it is successful, then it is in the running state or succeeded. After running, it is succeeded. But if pod is in the pending state and it is not able to run it, then it will be in the failed state. So these are the different states of the pod in the pod lifecycle. Okay. Now this is the sample of a pod manifest file. So first thing is basically when you are saying nginx, this is my file name, YAML file, right? API version v1. So what is the meaning of API version v1? So v1 is basically a API version which we can use for pod, replication controller and service. Okay. So API version when you are using, you need to mention the kind, means what you are going to create. I am going to create a pod. So I am saying kind is pod and API version is v1. So v1 means this table basically we need to follow this table whenever we are creating. If you are creating replica set, then you need to create apps/v1. Now I am saying name is nginx pod. Okay, so I think API version is clear. So it will be from this table and kind is pod. Metadata. So metadata is data about data. Data about data means data about this pod which I am going to create. So I'm going to create one pod now. This configuration file or this manifest file will help me to create the pod. So I'm saying my pod name is nginx pod. So if you see this, my name of my file is nginx pod. And labels. Labels is optional, but it is very useful. Basically, if there are multiple pods are running and you want to filter out some pods, then we use labels to we use labels with the selectors. So selectors are not in this manifest file, but we will see in the coming some manifest file. So there you will see that how to create the selectors, and selectors we can link with the labels. So, but labels are optional, but it is very useful. So how you are defining the labels? You define your own labels by saying that app is nginx and tier is development. Now this is the metadata. Next is the specification. So these four uh, components, API version, kind, metadata, specification, is commonly used in all the Kubernetes manifest file. So when I say specification, so specification means my containers, because this pod will have container. So my container name will be nginx container and the image which is running for that container is nginx. Let me explain this pod file or manifest file one more time. First thing what we need to do, we need to create a we need to create a XAML file. So this YAML file or YML file, this file is having the API version. So API version is basically depends upon the kind. So if you are using kind pod, then you can use the version v1 and you can refer this table. And kind is basically what you are going to create it here. This is related to pod. Next is the metadata. So metadata is the data about my pod. So my name of the pod is nginx pod and label is app nginx. These labels are optional. This is basically defining some properties of my pod. So say an example, I am saying application nginx and tier is dev. And next I am defining the specification. So spec is basically I am saying this pod is having the containers, and what is the container? My container name is nginx container and image is nginx. Pod is like the VM. No, pod is basically the which has the containers, right? So now let us see the demo of this. For demo of each and everything, I have created some files. So we'll go to that file. So where is this? Is not chef. So pods demo. Okay, so what we are going to do, this is the same file which I was talking about, and where I need to write the commands. Why you are creating the, because here we are using the manifest file. We will have that port number, but Rajwan, I'm answering your question, but that is required during the service. We will expose that. And Vibhakar, for your question, why we are creating this YAML file? Because manifest file which we are using, that is used for creating the port, and that is written in the YAML programming language. Okay, now what I'm going to do, and these all things should be on the master server. So I will go to the master server. Okay, I will clear the screen. Okay, now here I will create a folder. So I will say mkdir and I call it ports. Okay, I have created this folder ports. Now I will go inside the ports. Okay, I'm inside the port. Here I will create the file. So here is the step. First thing is that I'm going to create a file which is called engine export. You can give any name of the file. Okay, so but I'm following the steps. Okay, I'm pressing enter, press insert key, and now same code which I have explained you, I have written here. I will copy this, and these files are available on my GitHub, so you can refer it from there. Okay, so this file is the same which I have explained you. I'm saving this file. Okay, and now next is that I need to, so this YAML, this manifest file has certain syntax to execute it. So you need to write the kubectl create -f and your file name. So it will basically, this port get created with this create command. If you say delete, it will be deleted. Okay, so I'm creating this. So I'm writing the command to create the port. So I will go back to my master node and I will paste it here. So kubectl create -f nginx port.yaml file. Press enter. Okay, so now it is saying pod is created. So the pod is created with a nginx image. Okay, so there is a pod and inside that there is one nginx image. So if you want to see, so you can write kubectl get pod. Okay, so now you can see there is one pod get created and the name of the pod is nginx pod and it is in the ready state. It is running. So it is not restarted so far. 21 seconds ago it got created. Okay, so my pod is created. If you want to see more detail about the pod, you can use some options with the get pod command -o white. Okay, so here you can see some more details. So my pod name is this, ready, running, and now this you can see the IP address of your pod. And where it is running on the worker node. Okay. Yes, it creates the container also. Okay, now my pod get created. So I have created one pod which has this IP address, and inside this pod one container is running, and that container is nginx with the image nginx. See, these are the dynamic IP addresses, Bhagyanath. So it will be automatically get created. So you cannot change it. Okay, now this is done. My pod is get created. Now I have displayed it, I validate it. Now let us see what else we can do. If you want, see, every object, every API object which get created, pod is an API object. Every API object has one YAML format or the JSON format I can print it. So if you want to print this pod in the YAML format, so you can basically run this command. -O is basically options as a YAML. So now this is the YAML format. So it is basically talking about the my port status, my port host IP, and my port IP address, right? All that information it is showing it here. If you want to see in the JSON format, then what you can do, you can run instead of YAML, you can say JSON. So JavaScript notation it will show. Okay, so Amit wants to ask some question. Is it possible? Okay, 1 second, Amit. I will make you unmute. Where is the 1 second? Yeah, Amit, go ahead.
Yeah, Raman, just one question. The container, in the specifications, you have mentioned the name of the container and
1
the
second,
image.
let me open that. So,
In the YAML file
yeah,
specification, you have mentioned the container name is and image. That image, it is picking from the Docker Hub or
so it is the
where?
that is same, right? So that process is same. First, it will check in the local repository or local system. If that image is available, it will take it from there. Then it will check for the private
So
registry. If it is not there, then it will
if
go to
we
the Docker.
if we check the Docker commands to check the container, Docker is so it will show that this
Yes, it
container
will
is
show.
running nginx.
So where it is running on the worker node, right? So if you say Docker PS,
Yeah, yeah.
so there are other containers are running, but our Nginx is not running here. Why? Because it is running on the worker node. So I will go to the worker node. Okay, and here if I say Docker PS, so you can see Nginx is running here.
Okay. But you have executed these YAML file on the master node. Then why
In
it
the
is running
master
on
node
the
only.
worker
Because
node?
master is issuing the command, and commands are basically issued by the master, and execution will happen, the port creation and everything will happen on the worker nodes.
Okay.
So master is not going to
Okay. So
execute.
this
Master
way,
is a manager only.
okay, okay. So likewise, we can say the way we are using Docker images to create a containers, here we are using a pure pods to create a containers.
Right. So I have one port which has container. So container is running. Container is running in the Docker world, but it is now within the port.
The man. Okay.
Okay. So whatever the properties, so these containers are created by the Kubernetes. It is not created by
Yeah.
my commands.
Docker.
Yes.
Okay. Yeah. So the difference is only that if we create the containers using Docker, those containers will not be managed by the Kubernetes.
Kubernetes. Yes.
Kubernetes
This is
will
one
only
difference.
manage the containers which are created by the pods
Yes. So
using the
this
pod.
is the one advantage, but there are other advantages.
Yeah.
So once we run it, we will proceed to our course. Then you can see some more advantages as well.
Okay. So one last thing, when we create the first thing, when we define the CDI network for the pod in the initial when we are creating the pod, so that network will be same for that single pod.
No, that
And
is a complete network where all the port get run. So whenever there is an IP address assigned to any port, that will be in that port network range, CIDR range.
okay. And if I want to run again a same container in the same pod or a different pod, how we can
So
differentiate that?
if you run the same image, Nginx image, if you want to run and you want to create a new port for that,
Yeah.
okay, so then there will be a separate port get created, but that is not a real-time scenario. If it is already running, why you need it? Okay, so
So
but
suppose I
if
want to
there
run
is a
Ubuntu or CentOS. Actually, can you give me the real-time scenario of
okay,
running multiple containers running in a single POD?
so in single port there is very less kind of scenarios, but we can take one example. You have the web server and SQL server. Okay, you want these two servers is to be into a single port network. So when we are talking about the port network, we basically says that logically connected containers.
Okay.
Okay, so in the port, basically we group all those containers which are logically connected. So like web server and your what we call database server. So these are logically connected. So I club them together, and whenever I need a replication of my port, so it will create the. So say an example, you want 3 replication. So it will create 3 replication for my web server as well as for the database server. And this is not a real time scenario. I'm just giving you the example. This thing. So real time example is we are having only one container inside a pod, but you can have a
A
facility
real-time
to create
scenario
the.
of one container.
Yeah, in real time
Okay,
we
okay.
basically maintain one container inside a pod.
Mm-hmm. Oh, that's why one container inside a port I got it, but if I need to create 2 or 3 containers with a different images, so in the YAML file, how we can define that?
Okay.
That's
So
what my question is.
yeah. So that you can define it here, right? So here I'm saying container. So this is first name. You need to create another name,
Yeah,
okay, and
yeah.
image name. So you need to mention here. I'm not changing here because this is very much structured. You can try it offline. So this is name, and my name is a MySQL container.
Okay, okay. Yes, got it.
So there is some echoing. Okay, and here I will say image, and my image is MySQL. So this is second container within same pod.
Mm, okay, okay.
So now one pod with multiple containers. Understood?
Okay. Uh, and suppose if I want to create another pod,
Then you need to create
uh,
another YAML file.
and where we are defining the network pod network here, that's why I'm confusing.
Pod
See,
network is
automatically,
already
if it
created. So
no
pod
pod network you have created, right? Right. But here in the YAML file, you have defining this. Suppose I'm creating another YAML file with API version v1, kind is pod. So how this will this
this is
container
Nginx port.
how
So
we
this is
will
the name of my
get to
port.
know?
Then
Yeah.
you need to give the different port. If you give the
Okay.
same port name, then it will throw the error. This is
Yeah,
already
yeah.
exist.
I will give the different port name, but how will this be managed internally that this container will belong to this pod on this network, this container will belong to
Yeah.
this pod network?
That's why we are writing this manifest file. So this port, and if the one which I explained here, uh, this JSON format, right? So it gives me the complete specification of my port. You can see the port IP address, and phase is running, host IP address is this, and you can see some other information, status. So this is there any volume linked to this? Is there any policy is defined? So entire information is related to this port is.
So we can edit if we want to do any changes. We can edit those things
We
and
can
do a
edit
changes
this.
here.
Yes.
Okay.
But we need to add it into
Okay.
the manifest file then for edit purpose.
Yeah. What is the location of that manifest file? The same.
That you can keep it
Uh,
anywhere. So I have created one ports folder. Under that ports
okay. Okay.
folder, I
Okay.
have created that YAML file.
Okay. Okay.
Okay. Any other question?
No. No. Thank you.
Yeah. Okay. So one second. Rajwan is asking, won't be a conflict situation where they run. There will not be a same IP address, Rajwan. So there will be if you are creating two containers, then there will be if there are two containers, then one second, let me mute Amit. Then there will be two IP addresses, not one same IP address. We will talk about expose also. I will just give me some time. Okay. Okay. So Venkat is asking for MySQL container. What is that question? One second. Yes. So for that we need to open the ports, right? So we need to do the port forwarding, right? So that we will see that how to do the port forwarding. Just wait for some time. Yeah. So Rajwan, just wait. Yeah, wait. Just wait for some time. Yeah. So now my port is get created. Okay, through that manifest file. Now I have seen the information. But if you want to perform some more deep level of study of the port, then you can use the kubectl describe command. So I'm saying kubectl describe port nginx port. So what I'm doing here, I'm copying this and I will go here and paste it here. Okay, so this is the information or complete information about your port. So what is the type, whether it is in the ready state, or so it is basically from here the name of your port, default namespace it is running on the worker node. Okay, and this is the IP address of worker node, this is the IP address of your port. So all that information you can see. So if you feel that okay, there is, so you can see labels are also defined here, start time also it is mentioned here. So if you have something doubt, you can go and run this command and check the property. Now what else I want to do? I want to test it. My nginx service is running. Can I expose it? Can I go inside my pod network, or not pod network? Can I go inside my pod? Is it possible? Let us try that. So next step is that, and please follow these steps. These steps are very structured steps. So first you need to create this. Second, once you save it, you need to run these commands, create and display the ports. And third, I'm doing it test and delete. So I will clean up as well. I will delete my so Ola, that depends upon the internally. So Kubernetes decides that which node it needs to move the image. So there is that is it's the same question, Amit, you are asking. So it is not in our hand that on which worker node it is to run. It will be internally decided by the algorithm. And Kubernetes is basically one more thing I forgot, that Kubernetes is written in the Go language, Go. Okay, so there is an internal algorithm that's not in our hand. Now you want to go inside your container. So in the Docker we were using Docker execute command, and now I'm using Docker execute, nginx, port, and bin sh. So I'm going inside this. So this command kubectl execute -it interactive terminal, right? And I'm saying nginx -port bin sh. So now I'm going inside my pod container. Okay, so now I'm inside it, and now I'm saying ls. There is some its own, and now what I'm going to do, I'm going to create one HTML page. Okay, I'm going to create one test.html page, and I will keep it at location where nginx service files are available. So I'm not going in detail. This is the HTML page which says congratulations, you passed. So I'm copying this code as it is. You can copy it, and I'm just creating one test.html file under usr share nginx html folder. So I'm copying this. I will go here and I will paste it. Okay, so this is basically creating one HTML file, test.html file. Now I will come out of this. So now actually I want to prove that this nginx service is running. And to do that, I have created one more test.html file into the same location where nginx is running. Now, if you want to expose the port, then you need to use a service. Service we will talk in detail, but there is a service which is called of type node port. So node port is the service which is used to expose your port into a particular port. So I'm saying kubectl expose. So this is the command which is basically expose your port network to the external world. So I'm saying kubectl expose port nginx port -- type node port. So node port is my service, and it will expose on port 80. So it will be mapped to port 80. Okay, so let me just copy this. So if I go here, okay, so kubectl expose port, this is my port, and it is to be exposed with a service which is of type node port, and it is to be exposed with the port 80. Okay, so I will run it. Okay, now you can see service get exposed. So now if you say kubectl get service, okay, so you can see there is a service is running this, which is node port, and it is mapped to port 80, but it has given its own port number which is 31885. Okay, and this is the cluster IP. So we will talk about the cluster IP. Cluster IP is basically your which is within the network only. So service I am not explaining in detail now. Just this command I am explaining. I am exposing the port, which is the nginx port of type port network, and if you want to define the name, you can define the name of the services, and it is basically mapped to port 80 of my port Nginx port, because my Nginx application or web server is running here on port 80. Okay, now this is done. Now if you want to see I found one second. So this is done. So if you want to see the service detail, you can use the describe command. So describe command is used for the, so now I'm saying describe service. Okay, so it is saying this service running with the default namespace. So these are the labels and annotation. So this is important, which is the type, and this is important. This is on the port network. Now target port is port 80 for my port, and you can see here, and the external port number will be 31885. Okay, so now let us see, let me see, is there anything else? Get service we have already seen. Now we will go to open browser. So we'll go to the browser and we will take the my service is running on the worker node, right? So I will take this IP address and I will paste it here. Okay, and I need to use the port number, which is this one, 31885. So I'm copying this port and I will go here and paste it here. Okay, and press enter. Now you can see my Nginx service is running. Okay, so here my Nginx service, which was running on my port network, now it is running. Now if you want to see your test.html, you can write test.html. So you can see your test.html is also available. So with this example, what I have shown you, that how to create a port, how to create a container within a port, and how to expose that container image or your web server HTML pages onto the web browser through service. Rajwan, now I think it answers your question. So Deepak, it will be on the worker node because my port is running on the worker node. So Rajwan, we can assign this port also, but that is through the manifest file. But if we are using the command, then it is by default whatever the port it takes. Okay, let me unmute you, Rajwan. I think probably one second. Where is Rajwan? Yeah, Rajwan, I unmuted you.
Hello, do you hear me?
Yeah, I can hear you. Yes.
So you expose the port 80
Right.
for the end service, yes?
Yes.
But to be able to access the Nginx, the HTML, you must use the port 31885.
That's right.
This port is the port of the pod.
This is
that
the
right?
This is the port number which service will use, okay, to expose it to the external world or your browser.
Okay.
But if you want to give your own port number, then you need to create a manifest file.
It is the one which it is assigned to the pod that is running. I mean, every pod has a port. You explained to us that every pod has containers that are running
Right,
using some port,
right, right.
and 31885 is that kind of port.
No. 31A. So each container which is running within the port, it is running on port 80. Okay. Now I mapped
Okay.
port 80 with, because ports are running within the within within the port network, so it is not exposed to the external world. So if you want
Okay.
that ports to be exposed to the external world, then you need to use the services. Okay.
Okay. So this is the kube proxy that you explained to us
Right.
some hours ago.
Yes.
Okay.
So with the help of these services, you are going to, so I have used node port service, which is basically this type of service. What it does, it takes your port forwarding, it will do, and it will take the port number from your port, and it will create one new port ID or port number, and
Okay.
with that port you can access your containers web server onto the browser. And if you want to give that port number, if you see means that port number is not I don't understand 31185, how can I give it to the client? Then what you can do, you can define your own port number also, but for that you need to write the manifest file.
Okay. So in the manifest file, we can define the port.
Yes.
Okay. Thanks a lot. I understand now.
Okay. All right. Yes, Amit, you are right. We did not configure, it is automatically created, Vibhakar. Yes. So 31885 is the port which is created by the service, so that I can expose it. So Venkat, I think you are also clear because I explained the same thing. Okay. So now and this file is basically, we are copying the HTML file in the port, not in the container. So port is actually here. The port is, it has only one container, so I go inside the container only, and I can, if there are multiple containers, then you need to access with some port number. So at this moment you can consider there is only one container and we have only Nginx, so I'm going inside the container. Okay, Anand. All right. So now, actually, if you follow this, this file, so it is, all the things are very step by step. So you can see here, this is open the browser and using this HTML. And now I want to delete my service. I want to delete my port network. And to do that, what you can do, you can go here and you need to execute this command. kubectl delete service, your service name. So I'm going to delete this. Okay, so service is deleted. Same way, if you want to delete the port, you need to write kubectl delete port. Okay, and now my port is also get deleted. So what I did, I created the port, I executed my Nginx container inside a port, And then yeah, that is a separate thing, Bhaginath. You can take a backup. It's better. It's always better if you are deleting the port. Before that, if you want to take the backup, mostly we take the backup of the volumes. Okay, but if you want to take the backup of the containers, you can take the backup of the containers as well. Okay, so we have deleted as well. And this file, all these details, you can find it on my GitHub. There is my GitHub. So this is my GitHub, and you can go to the Kubernetes. Under Kubernetes, you can see the demo files. So we are done with the ports, how to create the port. So you can go with the order 1, 2, 3 like this. It is showing 110, but you need to go next thing which we will discuss about that configuration map. So what I expect you in the next class, before coming to the next class, please go through this lecture thoroughly. Because for me, it will be difficult to again explain this manifest file from the beginning. And it will be very easy you to understand as well. So if you go through all this lecture especially, then it will be easy for me to teach you what is configuration map, and because all are the manifest files and all are created in the YAML, and it has the same structure. It will have API version, it will have kind, it will have containers, labels. Okay, so that is what I would expect. In the next lecture, you are going to go through this today's lecture. Okay, so I can go to the next one, but it will take some time. So it will be better. We will discuss it on next lecture. What is meant by service? Service, you can think, Anand, like it is the communication between your pod and the external world. This service, the service which I have created. Yeah. Okay, so Bhaginath, you want to unmute you? So, okay, 1 second. So you can go to this link. This is the link of the installation. I will paste it here. Okay, so next week Kubernetes fully, yes. So we will complete Kubernetes in next class, Saturday. Yeah. What will be the next week? Same first on Saturday we will discuss about the Kubernetes, and Sunday I will start the Ansible. Yeah. Okay, so Bhaginath, okay, I did not get the answer. If you want me to unmute you, I can unmute you. Okay, so Bhaginath, let me unmute you. Bhaginath. Yeah.
Sir,
Yeah, Bhaginath, I unmuted you.
sir, you lastly deleted the pod.
Yes.
Yeah, sir, if we accidentally deleted a pod, is it possible to recreate the same pod?
We can create with the same, because we have the manifest file, and again you need to repeat the steps which I followed to create the.
So no need to take the backup.
No,
of
better to take the backup. Better to take the backup. So that is something which is a system admin job. They are going to take the backup of your Docker file system. Remember yesterday we talked about the Docker Swarm where all the files get stored, volumes. So it's better to take the backup first and then delete it. That will be a there will be a periodically backup setup, right? So which takes
not need to take a manually backup. Is it automatically create a backup?
Automatic backup is I believe it's not there. I need to check. I don't think that is there. But
Okay.
but yes, you can run the cron jobs, or and you can create some trigger points. If something happens, then take the backup. So that we can do. Mostly in the pod, if you save something, basically the purpose of the backup is to save the data, right?
Yeah.
So if you want to save the data, better to use some volumes. Okay.
Okay. Fine.
So if you use the volume, even though your pod is deleted or terminated, then your data is saved.
Okay. Fine.
So that way also you can think one of the solution.
Okay. Fine.
Fine.
Thank you, sir.
Yeah. Okay, guys. So we will wrap it up now, and we will meet next week. And please give that feedback, whatever you feel. And we will meet next week. Next week we are going to discuss Kubernetes and Ansible. Bye and have a good week ahead.